Good morning, students. In this lecture, we will discuss about addressing modes of 8086. Why we study the addressing mode? Addressing mode help us to understand the type of operations and the way they are accessed while executing an instruction. What are we going to study? Addressing mode. We will see the type of addressing modes present in 8086. We will study each addressing mode with an example. Okay, there are 8 major addressing modes are there. First one is immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, register relative addressing mode, base plus index addressing mode, base relative plus index addressing modes. First, we will discuss about immediate addressing modes. Okay, in immediate addressing mode, in this type of mode, immediate data is a part of the instruction. Okay, instruction data will be present in the instruction itself, appears in the form of successive bytes or bytes. Example, move AX, 10AB is the data. 10AB is the data that is present in the instruction. So that instruction, what is the meaning of that instruction? Means the direct data will be stored in that AX register. Okay. So the data will be directly stored into that AX register. Any data will be given directly in that instruction. That type of instructions are called immediate addressing mode instructions. Then second one is the direct addressing mode instruction. Okay, in this type of addressing mode, a 16-bit memory address is directly specified in that instruction as a part of it. Okay, a 16-bit address will be given instead of a data. So the data will be stored in that memory location. For example, that 5000H is the address, memory address. That 5000H will store the lower order byte 22, and 5001 stores the higher order byte 33. So that 22 will be moved to the AL register and 33 will be moved to the AH register. So the data previously, the data will be given directly in the instruction. In this one, the address will be directly given in the instruction. So that's why the address will be directly given in the instruction. That's why it is called direct addressing mode. Okay. So after the execution of the instruction, the accumulator contains, that accumulator means AX register contains 3322. This type of instructions are called direct addressing mode instruction. The address will be present directly. Then register addressing mode. In this type of addressing mode, the data is stored in the register and it can be 8-bit or 16-bit register. All the registers except instruction pointer may be used in this mode. Okay, so register addressing modes, only the general purpose register, that is a pointer registers or index registers are used, except that IP instruction pointer or segment registers also we can use. Only the registers are present inside that microprocessor except the instruction pointer. Okay, so the data transfer between the registers are called register addressing mode. For the first example, the first example, it is a 8-bit transfer. The second example is a 16-bit transfer. So after execution of this instruction, the BX contains a 10 AB. The data will be moved into that AX register. The fourth one is a register indirect addressing mode. In the register indirect addressing mode, the address of the memory location which contains the data or operand is determined in an indirect way using offset registers. Okay, so we are not giving address directly. Okay, that the address will be stored in the BX register. Okay, normally the address indicated by the parenthesis. Normally the address indicated by the parenthesis. Without parenthesis, they are considered as a data. Okay, they consider as the data. So that address indicates, the square bracket indicates that is the address. Okay, So the address will be stored in that BX register. So the BX register contains 5000. Okay. So after execution of that the memory contains 22, 32. 22 is a lower order byte, 33 is a higher order byte that will be moved into that AX register. So the address not given directly. Instead of that, the register contains the address. That's why it is called a register indirect addressing mode. Next, we'll before going to that continue the addressing mode. What is a type of addressing mode? This instruction. Any guess? Correct. This is a direct addressing mode because we are giving the address directly. So the data will be in that CX register will move to the address 7000. Okay, next we'll go to the indexed addressing mode. Okay, in that indexed addressing mode, in this addressing mode, the offset of the operand is stored in one of the index register. Previously, the address will be stored in that DBX register. Instead of that, the address will be stored in the index register. Normally, the default segment is DS data segment for the index register SI and DI. So the data will be moved from the address 5000 and 5001 into that AX. The 5000 will be stored in that source index registers. This type of so either source or SI or DI used in that instruction means that is called indexed addressing mode. Next, register relative addressing mode. Register relative addressing mode. In this mode, the data is available at an effective address formed by adding a 8-bit or 16-bit displacement with the content of any one of the registers VX, VP, SI, and DI. The default segments are DS or ES. So the instruction, the address will be stored in that BX register. So the BX contains 5000. The displacement value is 50. That is 8-bit displacement. The displacement value is 50. So 5000 plus 50, the final address is 50, 50. So that 50, 50 contains the data. Okay, 50, 50 contains the data. 50, 50 contains 44 and 50, 51 contains 33. 50, 51 contains 33. Okay, so that data will be moved into that AX register. Clear? Okay, there is a small mistake. This is a 5050. This is a 5051. Okay, next base plus index. A base plus index addressing mode. In this mode, the effective address is formed by adding the content of a base register. The base register may be any one of the BX or BP to the content of an index register, SI or DI. The default segment register is DS. Okay, so we are using two registers for calculating the final address. One register is the base registers, another one is the index register. So these register content will be added. Okay, BX contains 10,000 address. Then SI contains 20,000 address. So 10 plus 20, 10,000 plus 2,000. So 3,000 is the final address. The 3000 contains 12 is the lower order byte and 34 is the higher order byte. That is the data. Okay, that 3000 and 3001 contains the data. So that data will be moved into the AX register. So index register also store the address and base register also store the address. That's why it is called base plus index addressing mode. The last one, the base plus base relative plus index addressing mode. In the effective address is formed by adding a 8-bit or 16-bit displacement with the sum of the content of any one of the base register and any one of the index register in a default segment. Okay, so BX also contains address, SI also contains address. BX contains 1000, SI contains 2000. The sum of BX and SI will be 3000 and the displacement is 50. So 3000 plus 50, the final address is 3050. So the 3050 contains the lower order byte and 51 contains the higher order byte. That data will be moved into the register, AX register. Okay, some other addressing modes are also there. That is String addressing mode. The instruction of a string instruction uses the index register implicitly to access the memory. That is called string addressing mode. Example instructions are move SB and move string word, move string byte and move string word. The IO port addressing means we are using the two instruction in and out instruction are called IO addressing mode. The destination or a source of the data is an IO port, either direct port addressing or indirect addressing may be used. Then relative addressing mode means in this mode the operand is specified as a signed 8-bit displacement relative to the program counter. Okay, examples are jump and JNC. The implied addressing mode, the instruction use this mode have no operand. Examples are CLC, clear the carry, set the carry, complement the carry. Okay, so the main 8 addressing modes plus these 4 addressing modes. Okay, for 8086 addressing modes. Thank you.